Guys, welcome back to the recursive path. Today we are going to solve the question number 4 of problem Leetcode problem set, that is median of two sorted arrays. I hope you have watched the previous video of question number 3, that is the longest substring without any repeating characters. In case you haven't watched it, please do watch it. Please do check it out. And in case you have any doubt, please add a comment. I will get back to you on that. Without wasting any time, let's get started with this question. That is question number 4, median of two sorted arrays. Okay, let's first read the problem statement, what it is. So, given the two sorted arrays, that is nums1 and nums2, so it says that we have two sorted arrays, size and n respectively. Return the median of two sorted arrays. We need to return the median of two sorted arrays. And it also asks that overall runtime complexity should be under log of n plus n. So, this is the question. So, what is being given? We have a two sorted array. Let's suppose 1, 2, 3, and 4. This is my first array, and second array is 5, 6, 7, and 8. In this case, median of the two sorted array is going to be, if I merge it out, it should be 1, 2, 3, 4, 5, 6, 7, and 8. And since median is nothing but the middle element, in this case, the size is even. My middle elements are like 4 and 5. So my median is going to be 2 plus 5 by 2. That is going to be 9 by 2 equals to 4.5. Right? Now, in case if my array is of side or odd size, let's say if I add 9 here as well, then my 9 is going to be included. Then my middle element is going to be basically this one. So my answer is going to be 5 in that case. I hope you got the question as. But the question similarly, we do have also example like 1, 2, and 3. And if you look at it, the answer is going to be 2 because the size is going to be odd if you merge it. Similarly, this one also says that 1, 2, 3, and 4. And if I since it is even, 2 plus 3 by 2 is going to be 2.5, right? Similarly, we have some constraints as well. The size of the arrays M and N are basically at 1,000, and the total sum of both the arrays is going to be 2,000. Similarly, the number that is present within that array is going to be minus 10 to the power 6 to 10 to the power 6. So these are the basic constraints that we have. So let's talk about the brute force approach that we can think of. Brute force. So the basic approach that comes into my mind is basically what we can do is we can create. We can firstly merge both the arrays. Merge both the arrays. Then we can sort it out. Sort the merged array. Then we can find the middle element or find the mean. Find the not the mean, sorry, median. We can find the median. And median is going to basically, in case of even, it's going to be m1, that is middle 1, plus n2, that is middle 2, by 2. Or in case of odd, it is straightforward. Total size of is middle only m1, we can say that, right? So this is going to be a brute force approach. So to do this particular operation, basically merge both the arrays, it is going to be O of m plus n, right? To sort the merged array, it is going to be O of m plus n log m plus n, right? And final median is O of 1 only. So the total time complexity of this particular problem is going to be, since it is going to be O of m plus n plus m plus n log m plus n. This is how it is going to be like. So we can say it is going to be O of m plus n log m plus n only. So this is going to be a total time complexity for the brute force approach that I can think of, right? We can optimize this above approach as well by what we can say, since we are merging both the arrays, we can keep them in a sorted, we can merge them in a sorted manner only. How we can do that? Using this, let's say 1, 3, 5, and 7, something like this, right? And the second array is going to be 2, 4, 6, and 8. What we can do is we can initialize two pointers. Let's say P1 here, P2 here, and we can create a new array of size n plus n. 3, 4, 5, 6, 7. So let's say now both the pointer is start. So P1 and P2, we can compare both P1, all these are P1 and P2. Since one is smaller, I can append 1 and my P1 move to this position now. Now again we compare my P1 and P2, which is smaller. Since P2 is smaller, my P2 get here, being entered in this new array, and my P2 goes here. Similarly, now my again we can check my P1 and P2. Since P1 is smaller, we can say 3 is going to be added, and my P1 moves forward. So next again we check P1 and P2. Since my P2 is smaller, my P2 move ahead, and I also add the value in the array. So now again check P1 and P2, which is smaller. My P1 is smaller, so I add P1 and move ahead P1. Now again I will check P1 and P2. P2 is smaller, so I will add P2 and P2 moves ahead. Similarly, which one is smaller? P1 is smaller, so 7, and my P1 moves ahead. And similarly, we'll check P1 and P2. Since P1 does not have any value, I will just add the P2. That is it. So this in this manner, we can basically create a merged array. So we can skip this particular time
Not
complexity.
quite sure how
That
to
is this
do
one.
that.
In that case, what will happen is my total time overhead is going to get to of n plus n only, right? So that is my uh, optimized approach of the brute force. Now let's see how we can achieve the logarithm and time complexity. Uh, Let me just assume firstly two arrays. Let's say 1, 3, 8, and 9. That is going to be my x. My y is going to be basically the second array. It's a 7, 11, 18, 19, 21, and 25. So basically, one thing is given to us, that is both the arrays are in a sorted manner. So these two are going to be always in sorted manner. Right? Now, to achieve a logarithmic time complexity, we usually tends to binary search, right? So the first thing that comes into our mind is binary search. Now we need to figure out how we can find the median using the binary search, right? Okay, so median is nothing but the middle element, right? So what we need to find out is we need to divide our array, that is both the arrays, into two groups, into two buckets. Let's say, uh, or not even the bucket, let's say two halves basically, H1 and H2, and we need to find that correct positions such that uh, in both the arrays where we can make the cut such that the values in H1 is always smaller than the values in H2. And if we have done that kind of system, then what we can do is we can easily find out the median. Okay, let me tell you how. Just a second. So as we have taken the our example only, right? So what we can do is we have 1, 3, 8, and 9, and 7, 11, 18, 19, 21, 25. So let me just firstly sort this array. So 1, 3, 8, not 8. Let me just merge these arrays. So 7, 8, 9, 11, 18, 19, 21, and 25. Right. So this is going to be my array. Right. Now, what needs to be done is I need to figure out two, like my middle element, that is in this particular case. So it is going to be 1, 2, 3, 4, 5, 6, and 10 elements, right? So my middle element is going to be sum of both the middle element, that is this one, right? These two. And if it is going to be 9 plus 11 is going to be 20 by 2 is 10. So my median is going to be 10 here, right? But what we need to figure out is we need to figure out how can we divide my array into these two parts, right? Or if I can show you in this bigger example, it is going to be like this: 1, 3, 8, and 9, 7, 11, 18, 19, 21, and 25. So let's say if my put my cuts at this position and at this position in both the arrays. By what I mean is cut is basically going to divide my arrays, right? So this is going to be my x, this is going to be my y. And then if I put my cut and if I do this, something like this, then you can visually see that this is going to be my h1 and this is going to be my h2, right? So what we need to do is we need to figure out two points where we can cut my array in both the arrays such that my left half, that is this one, left half, is smaller than my right half, right? And how can we find the uh, middle element? So what we can assume, since the cut is going to be here only, right? What we can do is after this we can assume it is going to be plus infinity, and before this is going to be minus infinity. Similarly, it is going to be minus infinity and plus infinity, right? So what we can do is we can take, since we need to find the maximum, right? So see, so these are the two arrays. What we can do is the maximum of basically the minimum of these two elements and the maximum of these two elements. That is going to maximum is 9 and the minimum is 11. So 9 plus 11 by 2 is going to be 10. That's how you can find the what is it, the median, right? So let me just since this is just the what is it, to help you out how we can do this. Let's also think how we can find out these two particular cut points, right? Because we can visually see it here, but how we can find it in the code, let's see. Let's figure it out, right? So let me just write down once again the arrays. X is going to be 1, 3, 8, and 9. My y is going to be 7, 11, 18, 19, 21, 25, right? So how we basically do the binary search? We do it by taking two values, that is low and high, right? So my low is okay. Before even doing this, what we need to do is we need to always make sure that my x is the smallest array, right? Why we did that? We can discuss that at the very end of this particular solution, right? So since this is, x is already smaller, so it is fine. Now my low is going to be 0 because that's we are going to make the minus on this, and my x is going to be the high is going to be 4 because the size of my smaller array is going to be 4, right? And since we need to find the cut, right? Or what is it? The how we basically proceed with the binary search, right? Here I'm going to say is px. What is my partition of x? But we in basic binary search we say it's mid. So it is going to be low plus high by 2, right? Similarly, we need to find the cut in the on the y array as well. How we can find, since we know the size of both the arrays, what we can do is we can do as size of x plus size of y plus 1 to take care of the odd element. This one is basically added to for the odd elements by 2 minus p of x. Why p of x? Because we know that we have already chosen these number of elements, right, in the x. Since we know that my left already had these elements, in my right should be I need to decrement those, right? So that's why this one p of x. Now we need to see some more things. That is, let's see, let's calculate these values firstly. So in this case, my p of x is going to be low plus high by 2, that is going to be 2 because low is 0, high is 4. And p of y is going to be s of x is 4, s of y is 6 plus 1, 6 plus 7 plus 4, 11 by 2 is 5 minus 2, that is going to be 3. P of y is going to be 3, right? So what I can say, this is my p of x, this is my p of y, correct? And if you see left elements, total number of left elements going to be 5 and right elements also going to be 5, right? So yeah. Now let's say let me mark this as L1, L2, L3, or let's say not L1, L2, L3, L4. Let me just write that as L1, R1, L2, R2. Right. Now we are going this very visually, right? You can also understand that what we are trying to do here. Now our main goal is basically, what is our main goal? Our main goal is to make sure that we find the two cuts such that my left part is all the elements in the left part is smaller than the right part, right? So what we can do is, we always know that L1 is always going to be smaller than R1, but we need to make sure that L1 is also going to be smaller than equal to R2 as well, correct? So that is going to be my first condition, that my L1 is always going to be smaller than equals to R2. Similarly, my L2 also should be smaller than equals to R1, right? L2 is smaller than equals to R1. Why these two conditions? Let me show. So let's say, since we need to divide this array into two parts, let me just take the help of this. So if you look at something like this, right? Right. So what is happening? All the elements that is present in this, are these smaller than these? Not, right? Because 8 is here, right? This should not be here because I have 18 and 11 as well. Right. So what we are trying to do here is we need to find that. So I think this hopefully helps you out in visualizing opinion why this is going to be my final condition, right? Okay, so let's see. Let's figure it out. If my L1, now we are going to check, is my L1 is smaller than equals to R2? That is correct. First condition is true. But my second question, that is, L2 is smaller than equals to R1 or not? No, L2 is 18 while R1 is 8. So that is not true. So in that condition, what it says is basically we need to move our this partition to on the right side because my L1 is smaller. Sorry, R1 is smaller, right? So I need to move ahead so that my R1 will increase, and similarly I need to move backward in the second array. That is, my L2 will decrease, right? So that my condition will match, right? So what will happen is basically in this condition, my low is going to be increased by p of x plus 1, right? Since and what is this condition? Let me just write it down as well for you. Let me just write down the conditions as well. If my L1 is going to be greater than equals to my R2, right? basically this one. If opposite of this is true, that means I need to move left, right? Basically, I need to move left in this case. So my low is going to be, sorry, basically high is going to be p of x minus 1, right? Otherwise, if my L2 is greater than R1, if that is true, in that case, my low should be p of x plus 1, because I need to move ahead here and move backward in this y array, right? So since we have done this, we have found out this formula. What we are going to do is we are going to update our low. Now, since this condition is not true, this condition is true, I'm going to increase my low by px plus 1. Px is 2, so my low is going to be 3 now. Since my low is going to be 3, I need to again calculate my px. That is 3 plus 4 by 2 is going to be 7 by 2 is 3, right? So my px now is going to be changed to 3. So let me just write down as something like this. My px changed to 3. Similarly, what is going to change to my py? Py is going to be 11 by 2 minus px, that is 5 minus, now my 5 minus 3, that is going to be 2. So my py is going to be 2. So how my L1, L2 will change? Let me just do that as well for you. So now my position will come here, right? Because px is 3. So my L1, R1, and this is going to be my cut here. So this is going to be L2, and this is going to my R2. Now again, we need to check, is my L1, that is 8, is smaller than equals to R2, that is 2, 18. It is true. But my L2 is not smaller than R1, because L2 is 11 and R1 is 9, right? So that again means I need to move further ahead, right? So what we need to do is we need to again update my low by p of x plus 1. So again, p of x is 3 plus 1 is going to be 4. So my low is going to be 4 now. And my p of x is, again, we calculate p of x, it is going to be 4 now. And p of y, it is going to be 11 by 2 minus 4, that is going to be 1 now. So let me just help you with this as well. Let's redo this. Now, this is going to be my cut in this array, and this is going to be cut in this array. So this is going to be L1, this is going to be R1, this is going to be L2, this is going to be R2. Since you see that R1 is like out of bound now, right? So we can consume all the values that is present is going to be plus infinity, right? So what we can see here is my L1 is smaller than equals to R2. True. 9 is smaller than equals to R2, that is 11, right? So this condition is fulfilling. My L2 is smaller than equals to R1. Again true, because my R1 is plus infinity in this case, and L2 is 7, right? So what we can say, this condition is also fulfilling. So these are the two cuts which divides my array into the equal halves, as well as all the elements present in my left half is smaller than all the elements present in my right half, right? So this is how my half is going to look like in this particular condition. This is going to be my H1. Let me say it H1. And my H2 is going to be like this. This is going to be my H2, right? Now, what we need to do is we need to find uh, the median, right? How we can find the median? Since we know L1, R1, L2, R2, right? So what we can do is we can say my values, if you look at it clearly, if we do the merging, right? So we have already done the merge. So the maximum value that is going to come here is going to be the maximum of these L1, L2, right? So the max of L1, L2 is going to be 9, while the value that is going to be present here is going to be always minimum of R1 and R2, right? If we sort it out, so minimum of R1 and R2 is going to be 11, right? So 9 plus 11 by 2 is going to give me 10 here. But in case of, let's say, odd, my values is going to be max of L1 and L2. Max of L1 and L2 in case of my size is going to be odd. So that's how we can solve this particular question. I hope you got the gist how we solved it. Let's try to pull it out and on the Leetcode IT and see how we can solve with all the three approaches. I think you got the gist how we solve this problem, right? Now let's also discuss the time causality. So the time causality of binary search is basically of log n, right? Log n. That is the basic time causality. But in our case, we have like m and n, right? That is the size of the two arrays. So what we can say, we have the of log min of m comma n, right? Why are we choosing no? Because we have done the uh, binary search on the smaller array only, that is x here in this case. So we can always say our time causality is going to be of log m, and here m is always going to be M, sorry, this is again, M is always smaller. Right? That is the first thing. And I think at the start we have discussed as well that X is always going to be a smaller array. Why that is, why, now we discuss why this is going to be always the case, because firstly, we have to reduce the time complexity. That is the first thing. Second point here is, if you see that we are calculating Px and Py, right? My Px and Py, in case if I make my Py, that is like y array is the bigger one, in that case my these values, right, this value can go negative as well. So to avoid that condition, basically we need to always keep make sure that my x is always going to be the smaller in size. I think hope you got the gist, and also the time possibility. And yeah, let's start with the coding on the Leetcode editor. Okay, so let's start with the coding. So first we do the brute force, but we know that brute force is not going to work because already the time already knows this of log m plus n, right? So let's try to code it out, and then we can move to the most optimal one. Creating two elements, that is m and n for the length, right? So int n m is supposed to be nums1 dot length, and int n to be nums2 dot length. Nums2 dot length, right? Now we also need to create one merge array, that is going to be int merge equals to new int m plus n size, right? Now we need to add the elements for int I equals to 0, I equals to m I plus plus. What we need to do is we need to add the element in the merge array, right? So my merge of I is going to be nums1 of I, right? Similarly, now I need to copy the next array, that is int I equals to 0, or I can say int j equals to 0, j is smaller than or equals to n, j plus plus. What we are going to do is we're going to do the merge of m plus j, right? Why m plus j? Because we have already filled that, right? So we need to move to m plus j, right? So what I'm doing is m plus j is going to be nums2 of j, right? Now what I need to do, I need to sort the array. So my array is not sort merged. So the time of this is going to be O of m plus n log m plus n, right? Now what I need to do is let's calculate the total as well. Total is going to be m plus n, right? Now what we need to do is basically we need to see if my total modulo 2, that is, let me just add the spacing as well, total modulo even, right? In that case, I need to return my merge of total by 2 minus 1 plus merge of total by 2 by 2, right? Point 0, because it is double, right? So what I can do is, I think you can visualize this better like this and this, right? So what I've done is I've found the middle two elements and divided by 2. Otherwise, if it is odd, then I just need to return merged of total by 2. So I think, yeah, well, this is the really brute force. We're just creating a merge array. Now we are sorting it and just running a median, right? If I run it out on the given test cases, hopefully it will run. I think we have done something wrong. What it is, okay, we have forgot the semicolon. Yeah, so if you see, all the test cases will pass, but if I try to submit it, it won't work because my time slot is going to be off. Oh, interesting. It worked. Ideally, it should not, because the time of this is basically of m plus n log m plus n, which is way higher than the logarithm library. But somehow there is the test cases which are like present here might not be the best one. That's why it has worked, but ideally should not work. Similarly, let's see the uh, optimized one. So let me just remove these. So I've all kept m and n, right? Now what I need to do, I need to again create a merge array. That is my merge equals to new int of size m plus n, right? Now what I can do, I'm going to create three variables, I, j, k. My three variables, so basically I and j are going to be iterator of nums1 and nums2, while k is iterator for merge, right? So what I'm going to do, I'm going to create a while my I is smaller than m and while j is smaller than n. I need to do something that will basically fill my array, right? How I'm going to fill my array? I'm going to check if my nums1 of I is smaller than or equals to nums2 of I smaller than j. In that case, what I'm going to do is, right, merge of k plus plus is going to be nums of I plus plus, right? Hence, merge of k plus plus is going to be, basically it is going to be nums1, it is going to be nums2 of j plus plus. So what I'm doing here is we are finding the lower element, and if we found that, we just add that element and we are incrementing their counters, right? Now, since we found this, we need to also make sure that we fill the rest of the element if it is left in any of the arrays. So I is not the name. What I need to do is let me just add the spacing as well. Yeah. If it is done, then merged of k plus plus is going to be nums1 of I plus plus. Similarly, merged of j is not than n, merged of k plus plus is equals to nums2 of j plus plus, right? So I'm just filled the rest of the element that is present. Now again, what I need to do is I int total is going to be m plus n. If my total modulo 2 is equals to 0, that is even, in that case I need to return the same thing, that is my merged of total by 2 minus 1 plus merged of total by 2, and we are going to divide it by 2.0 because we need to return double, right? Else, if that is not true, I just need to return merge of total by 2, right? So what we have done, we have just like kind of merged the array in the sorted manner only. That is going to take off m plus n, and we have just written the elements, right? So median element. If you look, it should work if you write it correctly. I'm just running for the given test cases. I just taking too long. Again, we forgot the semicolon. Interesting at the same place. So one, yes. If you look, we have done the it is running for the test case. Now let's try to submit it. Ideally, it should not submit m plus n, but it is getting submitted because the test case that is present in this particular question is like not up to the mark, so that we cannot test the exact time usability. But the continuity for this approach is going to be m plus n. Now let's move to the most optimal one. Let me just remove all of these. Now, since we are getting the m and n, we need to make sure that my m is always, if it is greater, then I need to make it smaller. Then I just need to return find median of basically this only I. And just need to call this with the opposite values. That is, here it is going to be nums2, nums1, right? In the opposite manner, because then my call will have like m is smaller than n, right? So this is how we are going to solve this, the smaller one. Now, what we need to do is basically we need to calculate the low, that is 0, int high, that is going to be m, right? I need to take a while low for the, what to say, the binary search. While low is more than equals to high, I need to do some work, right? Now, what we need to do, we need to find the partitions. So what we have called previously is going to be px and py. Let me just call either the similar, let's say partition 1 is going to be low plus high by 2. Let me just add the brackets as well. Yeah, high by 2. And then partition 2 is equals to m plus n plus 1 by 2 minus partition of 1, right? So what it gives me like two partitions that we already think of, right? Now we need to calculate L1, L2, L1, R1, L2, R2. So my L1 is going to be, in this condition, I'm going to use a tertiary operator. So if my partition 1, if it is equivalent to 0, in this case, what will happen? Basically, it can be integer dot min value, right? That is going to be negative infinity because my partition is at 0. So all the left values, basically, I don't have any left value, right? So all the values going to be minus infinity. Otherwise, if it is not 0, in that case, it is going to be nums1 of partition 1 minus 1, right? So this is how we interpret the L1. Similarly, R1 is nothing but if my partition 1 is going to be of size m. In that case, all the values on the right hand side is going to be integer dot max value, right? Which we have discussed as well. So it is going to be nums1, comma, partition 1 plus 1. Not plus 1, it is going to be partition 1 only, right? Similarly, my int m2 is going to be, you just need to copy paste it. It is going to be partition 2, it is going to be partition. Similarly, for my R2, it is going to be the similar thing. Just that. It is going to be partition 2, it is going to be n, it is going to be partition 2. Now, since I calculate L1, L2, R1, R2, what we need to do? We need to check for our any condition, that is if my L1 is smaller than equals to R2 and then my L2 is smaller than equals to R1. If this condition is true, and we need to check the size now. If my m plus n modulo 2 is equals to 0, let me just get in the brackets. M plus n modulo 2 is equals to 0. In this case, that is basically going to be even, right? So total number of elements is even. So I need to return math dot max of L comma L2 plus math dot min of R1, R2 by 2, 2.0 because of a double right. Otherwise, else I need to just return maths of L1, L2. Right? Now we need to figure out the update condition as well. Update condition is going to be else if my L1 is greater than R2. In that case, we need to move on the right left hand side, right? So I need to my high will change into partition 1 minus 1, right? Otherwise, that is my L2 is greater than R1. In that case, my low will be moved to partition 1 plus 1, right? So I'm moving to right hand side on the smaller array, right? And it is always guaranteed that we should find the element and return it from here, middle. But just for the sake of, we are just going to return negative minus 1. That's it. Just for sake of the completeness on here. And if we run this code, it should work. But let's see. Okay, this is going to be smaller m. Simplification is always there. Index out of bound. What we have done. Okay, it is coming. Partition 2 m plus n. I think we have what it is. We need to do it. We have not changed the non-stop. So if we do it now, that is the problem with the copy pasting. So if we copy paste it right now, it is running for all the test cases. And if I try to submit it now, what it will work and it will be of log min of mn. So now if you see, it has beat all the 99.54% of solutions right. So I hope you like this video. And in case you have any questions, please add a comment. And thanks for watching. That's my time. Thank you.